Okay, guys, what we have right here is just your basic line segment. In this case, my line segment's name is AB. What we're trying to find here is we're going to find the perpendicular bisector to line segment AB. So in order to find a perpendicular bisector, we got to break it down into two words. First word is perpendicular. Second word is bisector. When you hear anytime that you hear the word bisector, what you're thinking is this. I'm thinking of something that cuts it in half. So in this case, I need a line or a line segment that cuts line segment AB directly in half, and the way that it does it, it's going to actually create a right angle. Okay, now before we actually draw the perpendicular line, we have to find out where is the midpoint. Midpoint is the word it sounds, or it is exactly what it sounds like. I need a point on this line segment that is directly in the middle. So you'll see here from this this action that D is the midpoint, or the point directly in between A and B. Now what we need to do, here's the other thing that you find out with the midpoint. The distance from A to D is exactly the same as the distance from B to D. Okay, so when I bisect something, I have created two equal segments. Second part of what we're doing right here is now that we have the bisecting spot, now I need to create a perpendicular line that goes through that. Okay, so now the new line that we've drawn right here, you can see that we have created a right angle, or an intersection at a right angle, at a point that is directly in between points A and B. Okay, guys, triangles have some special qualities, and some of the special qualities are that I can connect some lines that I can create within it. What we just did with the perpendicular bisector, we can actually find three perpendicular bisectors within a triangle. Every single side of this guy, we can put a perpendicular bisector on it, and then something interesting happens in the end. So right now we're going to create the three perpendicular bisectors. Again, what is that? I've got to find a midpoint, and then I'm going to draw a line that is a 90-degree angle where it intersects. Now, something interesting that you'll see here as well about the perpendicular bisectors is that they are lines. Okay, and these lines extend on and on forever. So do not feel like, for whatever reason, that you ought to have a perpendicular bisector where it's just a given length of segment. That line goes on and on forever. Okay, now that we've got our three perpendicular bisectors labeled right here on triangle AEB, we can now see that what's interesting about it is that all three of the perpendicular bisectors, they intersect at one particular point. That point right there is called the circumcenter. Now here's how we're going to put them together. Perpendicular bisector. What does perpendicular start with? It starts with a P. A P is a consonant. Circumcenter is the point of intersection right here, or the point of concurrency. Circumcenter also starts with a consonant. Okay, so keep those together. P is a consonant, C is a consonant, and they go together. The interesting thing about a circumcenter is that the distance from that point, I in this case, to point A in this case, or another vertex, it's the same for all 3 points. So the distance from IE to IB and also to IA, all three of those distances are exactly the same. And that's the big idea about a circumcenter. It is equidistant to the vertices. Now, another thing that we can do right here with this particular triangle, the triangle that we have is an acute triangle. So you can see as this guy starts to move a little bit, that it starts to stretch out, and now it's approaching 90 degrees. So now here, angle B down here, angle B is a right angle. Now let's take a look at something. Where is my circumcenter now? Now the circumcenter in a right triangle, if you'll keep in mind, guys, the spots that are on here, the little red spots that are on the sides, those are all midpoints. So when I have a right triangle, the circumcenter occurs on the hypotenuse of that triangle at the midpoint of the hypotenuse, right? So that's a big, big key right there. Now you'll also see that as the triangle gets wider and angle B gets larger and larger, now we have an obtuse triangle. Now where did the circumcenter go? Now that guy is split, man, he left the building. He's outside of the triangle. So an obtuse triangle has got a circumcenter that's outside the triangle. A right triangle has a circumcenter that is on the hypotenuse at the midpoint. And the first one that we did, an acute triangle, its circumcenter is inside the triangle. So again, guys, Perpendicular bisectors create the circumcenter. The circumcenter is equidistant away from the points. Obtuse triangle, circumcenter outside. Right triangle, circumcenter on the hypotenuse. Acute triangle, circumcenter inside.